19. Let us look at dimension for heat capacity, no specific heat capacity. Heat what? Heat capacity. For the specific heat capacity, the symbol is what? The small letter C. To know the dimension from Q equal to the what? MC, changing what? MC theta. And this C here is specific heat capacity. Make another formula Qm over theta. And this Q we have here is what? Is energy. What is the dimension for energy we have here? The quantity of heat. It is what? Energy. The dimension for energy is M L square T minus 2. Dimension for mass is what? M. Dimension for theta is this. This cancel this. We now have what? L square T minus 2 and theta minus 1. This dimension for specific heat capacity. So, the next one is what? 20. Dimension for heat capacity. So, for the heat capacity is known as what? As Q equal to what? MC without theta. So this M is what? Mass. This C is what? Is specific heat what? Capacity. So you will now say what? The heat capacity Q is equal to the what? MC. Dimension for M is what? Capital letter what? M. Dimension for this C, heat capacity is what? L square T minus 2 theta minus what? 1. The dimension for heat capacity that will be what? M L square T minus 2 theta raised to power what? 1. This is dimension for what? For heat capacity. Number 21. Dimension for latent heat. The symbol for latent heat is R. So from formula Q equal to the what? ML. So for this latent heat here, L will be what? Q over what? Over M. This Q is not this one, no. Is the energy, the one we use here. So what is energy? So it will be what? M L2 minus this over what? M. It will cancel each other. You now have what? L square T minus 2. Number 22. Dimension for entropy. What is entropy? Entropy X. Entropy is the disorderliness of a system. Degree of what? Of disorderliness of system is called what? Entropy. And to know the entropy, the formula for entropy is change in S equal to the what? H over what? Over T. So our entropy X, it should be what? Heat energy H over T. What is this heat energy? This change is it as what? This energy here. You now have what? ML2 minus 2 over what? Over T. So the dimension for entropy will be what? ML2 T minus what? Minus 3. I said I'm going to do what? 30 dimension quantity. Abi? It's like what? I'm left with what? With 8. Number 23. Dimension of Surface tension. So surface tension is what? Force per unit length. The measure for force is L, no, is M L T minus 2 over L. Cancel each other. We have M L minus 2. Sorry? T minus 2. So the next one is what? 24. Dimension for coefficient of survey of viscosity. Coefficient of viscosity, its symbol is this, is force per unit area multiplied by velocity gradient, or multiplied by what? Velocity what? Gradient, velocity per unit length. Dimension for force is M L T minus 2. Area is what? M square. Velocity is what? LT minus 1. For length is L. This cancel this. You will now have left with what? M LT minus 2 over what? M square T minus 1. When it go up, sorry, area is not M. Oh. Don't mind me. It's R. So it's R. We are left with what? L square T minus 1 to give you what? M L minus 3 T minus what? Minus 1. This is dimension for coefficient of what? When L go up, it become minus 2. Minus 2 plus 1. It will be minus. Sorry. The next one is 25. But dimension for Planck constant, which is what? H. So to know dimension for Planck constant, from this formula, E equal to the what? HF. So this H will be what? E over what? Over F. E is energy. What is dimension for energy? Is M. Dimension for energy is M L square L what? L square T minus what? Minus 2 over dimension for frequency is what? Minus T. Abi? So if you solve it further, we have M L square. If T go up, it become 1. Dimension for Planck constant. The next one is what? 26. Dimension for quantity of what? Of charge. Dimension for what? For quantity of what? Of charge, which is what? Q. And this Q is equal to what? IT. Dimension for I current A, dimension for T is this. That's all. The next one, we are left with 4. I said I'm going to 30. 27. Dimension for electric potential. This is also called what? Potential difference, V. And dimension for electric potential from power. Electric power equal to the what? IV. So electric potential V will be what? Power over what? I. Power is what? ml square by what? 3. Current is what? Is A. You will now have what? ml square T minus 3 A raised to power what? 1. This is the what? Dimension for what? Electric what? Potential. Number 28. Dimension for capacitance. Capacitance C. So the capacitance can be measured by what? From Q equal to what? CV. This is the quantity of charge, yeah? This V is electric potential here. So C will be what? Q over what? V. What is dimension for Q? Q is what? A T. What is dimension for V? Everything you have there. M L square T minus 3 A bar. M go up first. Minus 1. L go up. Minus 2. T go up. It become plus 3. Plus this one. Plus what? 4. A go up. It become what? A 2. This is the dimension for capacitance. Number 29. Dimension for electric field intensity. Which is what? E. So field intensity is what? Force per unit what? Charge. Dimension for force is M LT minus 2. Charge is what? Is AT. So we are now have what? M L T minus 3 per current. Number 30. Dimension for electric flux. This is symbol. An electric flux is the product of electric field intensity times what? Area. So what is the dimension for field intensity? Is M L T minus 3 times what? Area. Area is L square. So field intensity will be what? Let me write it here. To be M L times 3 T minus 3 A minus what? 1. So that is 30. Let me add 2 more extra. Dimension for resistance. Opposition to the flowing of current in what? In circuit. Resistance is R. V over what? I. What is dimension for V? Electric potential is M L square T minus 3 A1. Current is what? Is I. It will now become what? M L square T minus 3 A minus 2. The last one is dimension. Let me put it here. 32 for ID gas constant, which is what? R. From this formula, PV equal to the what? nRT. Make as well the formula R will be what? PV over what? NT. Pressure is what? L by 1, T by 2. But volume is what? L cube. Dimension for amount of mole is N. Check it here. Amount of substance N. Dimension for temperature is what? Is theta. So you now have what? L minus plus 2, T minus 2, number of mole minus 1, theta minus 1. If I want to write dimension of various physical quantity, in fact, it's never possible. I cannot do it all. There are many. So this is where we are going to stop for dimension, quantity, and dimensionless what? Quantity. So in my next class, I will start from dimension analysis or application of what? Of dimension. How are we going to what? To use dimension to what? To derive formulas. How are we going to use dimension to what? To derive unit of what? Of physical quantity. How are we going to use dimensions to check homogeneity of what? Of equation. Good day. See you in the next class.